Right, hi guys. So today we're gonna start a new chapter, chapter 3, Redox. Redox. So what does redox mean? It's actually a short form for the term reduction and also oxidation. Now, so if question asks you, hey, what's the meaning of redox? It means a reaction where reduction and oxidation reaction take place simultaneously. That means at the same time, right? Now, I'm sure that you are quite familiar with oxidation. Okay, where's an example of oxidation in your daily life? Very simple. You cut an apple and it turns brown. Oh, why? Why the apple turns brown? Simply because you have exposed it to the air and the air contains oxygen. Alright, so that's the meaning of oxidation. So the first thing you know about oxidation is basically something gain oxygen. Am I right or not? Okay, very good. That's a very good idea. Keep it up. So now, other than oxygen, we have some other ways to define the term oxidation. Yes, so first thing first, for this chapter, we will learn how to define oxidation and reduction. Now, there are four ways we can define oxidation and reduction. And what are they? First thing first, oxidation. For you to memorize the definition, you have to memorize this mnemonics, OHIO. So what does OHIO mean? OHIO actually means oxygen, hydrogen, okay, electron, and lastly, oxidation number. So if question asks us to define oxidation, how are we supposed to define oxidation? Okay, you can say it means gain of oxygen. So that means when something gain oxygen, they undergo oxidation, or when they have a loss of hydrogen, that's also a form of oxidation, and also loss of electron, also oxidation, and last but not least, an increase in oxidation number. So any one of these four will be how you define oxidation. So how I memorize this is very simple. First thing first, you memorize OHIO, OHEO, oxygen, hydrogen, electron, oxidation number. Then the term oxidation sounds very similar to oxygen, so it's a gain. Oxidation and oxidation number, they're referring to the same thing, right? So oxidation means increase in oxidation number. Hydrogen and electron, the word is totally different from oxidation, right? So it means a loss of hydrogen and electron. As simple as that, okay? Right, this is how you define oxidation. Next, how you define reduction? Simple. Reduction is the exact opposite for oxidation. So how you define? Loss of oxygen. That's reduction, okay? The second definition, gain of hydrogen. Or you can define reduction as a gain of electron. And last but not least, a decrease in oxidation number. As simple as that. Alright, okay, so this is the four basic principles that you will use throughout the entire chapter for redox. Okay, we have to apply all this. So now let's look at the first reaction, which is a redox reaction here. Now, we will be looking at the examples of all these four definitions, but first thing first, for today's lesson, we'll only cover what is redox based on oxygen and hydrogen, and here are two examples that I have for you. Now the first example, let's look at this one that we have over here. CuO, copper oxide, react with Mg. Okay, Mg is more reactive than Cu, so during this reaction, the Mg kick out Cu. It becomes MgO. Alright, it's still the oxygen from Cu. Then Cu being a less reactive metal, have to stay alone lah. Okay, so this reaction, CuO plus Mg becomes MgO and Cu. Now, look at my CuO. From the beginning until the end, what has happened to it? CuO to Cu, it undergo a loss of oxygen. Loss of oxygen. So if CuO has lost oxygen, we say this substance undergo reduction, reaction, right? Reduction, reaction. So how are you going to explain this reaction in terms of redox? The first point that will give you mark is you have to mention CuO undergoes reduction. And why does it undergo reduction? Because it has lost oxygen. Simple. Alright. Next, look at Mg, my another reactant. Mg going to MgO. Somehow it has gained oxygen. So it has gained oxygen means it undergo oxidation. So I will explain here. Mg undergoes oxidation because my Mg gain oxygen. I'm done. So if this question is a 4-mark question, ask you to explain this reaction based on redox, this is how simple it can be. Alright? Okay? Alright. Okay, so we have done explaining redox based on oxygen. Now, we are going to explain redox based on hydrogen. So look at my second example over here. I have H2S, hydrogen sulfide. Hydrogen sulfide, react with chlorine, end up becoming sulfur and hydrogen chloride. So for this reaction, now you can actually pause the video and tell me who undergo oxidation and who undergo reduction. Right, so have you found the answer? Okay, now let's check. Let's check, see whether you really understand the concept or not. Okay, so now look at the H2S here. H2S, from H2S ended up becoming S. So very obviously, I can see a loss of hydrogen over here, right? Hydrogen, H2S, disappear to become S only. It's a loss of hydrogen. So H2S undergo oxidation, right? I bet this is an easy one for you. Right, then look at chlorine from Cl. Suddenly, it has gained a hydrogen, right? Gain hydrogen. So chlorine undergo reduction. So similarly, when I explain this reaction, I would say H2S undergoes oxidation because it has lost hydrogen. And on the other hand, chlorine undergoes reduction because it has gained hydrogen. Simple as that. Alright? Okay? So this is how you identify a redox reaction and how you explain them based on oxygen and hydrogen. So I hope you are clear with this. Now, something additional that we'll need to know for this redox reaction is we have these two terms here, oxidizing agent. Okay, usually I'll just simplify it as OA, and reducing agent, which I simplify it as RA. So what does OA and RA mean? Okay, this is where students always get confused. So maybe you have to be more patient when it comes to this one, okay? Right, so what's the meaning of oxidizing agent? So oxidizing agent means it is a substance that oxidizes another substance. All right. So oxidizing agent means it oxidizes something else. How do you know something has oxidizes another thing? Very simple, ni. It's very simple. So if you oxidize another person, that means you are yourself, okay? Itself undergo reduction. So for the example 1, how do I know who is the oxidizing agent? You just look for the reactant that undergoes reduction. So who is the one undergo reduction in my first reaction? CuO, am I right? So CuO undergo reduction. That means it is an oxidizing agent. As simple as that. Okay? Alright? Okay. Now, what's the meaning of reducing agent? As you can predict, it actually means reducing agent actually means it's a substance that reduces another substance. And how you identify? Very simple, because it reduces another substance, it itself undergoes oxidation. Okay. Right, itself undergoes oxidation. So now, come back to this example number 1. CuO react with Mg. In this reaction, who undergoes oxidation? Mg undergoes oxidation, right? Mg undergoes oxidation. So if I undergo oxidation, so I myself is a reducing agent. Alright, as simple as that. So now it's your turn to tell me, for example 2, who is the oxidizing agent, who is the reducing agent. Okay, so please find out the answer. Okay, so thank you. This is what we have covered for today's lesson is about the basic definition for redox. And we have also covered some examples that involve defining redox based on oxygen and hydrogen. And last but not least, you must be able to identify in a reaction who is the oxidizing agent and who is the reducing agent. Right? So in the next lesson, we will see examples of redox reaction based on loss or gain of electrons. Alright? And that will require some basic idea of writing ionic equation. So you may recap on ionic equation first. Alright? Thank you. Bye-bye.